All right, so we are starting chapter unit 4A today. We skipped section 4.1 because 4.1 is right triangle trig, so SOHCAHTOA. The basics of it that you did in IAG, what you did in Algebra 2 with trig. So we know that you guys know how to do that already, so we're going to move past that and use it later. And we're going to get started in section 4.2. So section 4.2 is degrees and radians. So knowing angles and degrees, knowing angles and radians, how to convert from one to another, things like that. Okay, so first off, some vocabulary. So first off, we're going to talk about the standard position of an angle. We have two different types of angles. We have positive angles and negative angles. So first off, all angles start from the positive x-axis, or 0 degrees if you're looking at the unit circle. So this right here, this side right here, it's my positive x-axis. This is called the initial side. So this is the initial, I-N-I-T-I-A-L. I have to spell it out loud. So many I's. Initial side. Okay, and then we also have our terminal side. So initials beginning, terminals end. So now if to go in a positive direction, you are going to go counterclockwise. So positive angles are drawn by moving counterclockwise. So if I want to draw a positive angle, I have to go in this direction. Okay, I'm not going to go that far. I'm going to stay in the first quadrant here. And I'm just going to draw a terminal side in my first quadrant. This right here is called the terminal side. And then once again, this right here is the angle. So this is your positive angle because you're going counterclockwise. A lot of times the angle has a name. I'll call it theta. Okay, you can call it alpha or A or X or whatever. And then once again, this is 0 degrees right here. Okay, so that's where it starts at the positive x-axis, counterclockwise, positive angles. Okay, so then let's talk about a negative angle. So once again, you always have your initial side. Your initial side starts at 0 degrees at the positive x-axis. But this time, if you're going to draw a negative angle, you're going to move clockwise. Okay, so if I come back to this one right here, there is a negative angle drawn, okay? But if you look at this right here, this is telling you that we're talking about that angle. But I could have gotten rid of that arrow completely, like that, gotten rid of theta there. And I could have said that this is my angle, and that's a negative angle right there, okay? So we'll draw that over here. All right, so let's do that. So let's draw a negative angle. So I want to go clockwise, so I want to go in this direction. Once again, I'm going to stay in this fourth quadrant right here. There's my terminal side. So this is initial side. This is the terminal side. And then my angle goes clockwise in this direction right here. And I can call that theta if I want, and this is a negative angle. Right there. Okay, so that's some vocabulary that you need to know. That's some facts that you need to know. What positive angles look like, what negative angles look like. You do not ever have to label your initial side and your terminal side. In fact, you technically never really have to draw your initial side because your initial side does not move. It's the positive x-axis. So if you don't want to draw, you don't have to. I'll probably start by drawing it, and then in the future I might not. Who knows? Okay, so let's do some angles measured in degrees. We're going to draw each angle. Okay, so all of our angles start at the positive x-axis. So I'll start by drawing my initial side. So the next thing I have to do is there's 2 points to this. Like if I was taking a test, there's 2 points. There is showing the terminal side in the correct quadrant and then showing the correct direction, either clockwise or counterclockwise. Okay, so 120 degrees is positive. I know that I have to go counterclockwise. So I have to go 120 degrees, so I have to make sure I know what quadrant I'm in. So remember, so that we're naming these properly, this is my first quadrant, second, this is my third quadrant, and this is my fourth. Okay, a way to remember it is that it forms a C if you go from first to fourth. Okay, so I want to know what quadrant I end up if I have to go 120 degrees. So think about it as each of these are 90 degrees here, and I have to go not 90 degrees more than that, so I'm going to be in the second quadrant. Okay, so I'm going to go into the second quadrant, approximately 30 degrees, and then I'm going to say from my initial side to my terminal side. That's my angle. All right, let's try another one right here. So positive x-axis, I'm going to start it. That's my initial side. Now I need to go negative 180 degrees. So negative, I'm going to go this direction, which is clockwise, and I need to go 180 degrees. So I'm going to go 90 and 90 more, which is going to end my terminal side. Oops, I want it to be nice looking. End my terminal side at the negative x-axis. So realize if I don't label the direction, I don't know if it's a positive 180 or negative 180. Even though they're equivalent, they're not, the angle itself is not equivalent. Okay, the measure it is. All right, so there's my angle. Okay, the next one is 540 degrees. So if I asked you how much is a full rotation, which I ask you right down here, a full rotation is 360 degrees or 2 pi radians, right? That's a full rotation, okay? So if I want to go 540 degrees, that's more than a full rotation. So to figure out how much more, because we do need to know how much more, I'm going to do 540 minus 360. 0 minus 0, 0. There's 8. 4 right there, 1. So 180 more than 360. So what I'm going to do is I'm going to go start at my initial side. Now, since it's positive, I'm going to go in this direction. I'm going to go counterclockwise, okay? So I have to go 360 degrees, so a full circle, and then I have to go 180 degrees more, okay? So if I go 360 degrees, I'm going to end up back where I am. And if I go 180 degrees more, I'm going to end up over here. So that's where my terminal side is going to be. But now I have to draw that. I'm not just drawing this because that's only 180 degrees. I'm going to go 360 degrees, which is that much. Well, I didn't want my pen to do that, so I'll stop when I get there. But then I'm going to keep going until I hit 180 degrees. So here's 360, 90 more, 180 more, and it would stop right there. So that's what 540 degrees looks like. One thing that you should realize is that when you start this, it should always be on the positive x-axis. You can't start it at any other axis. All right, next one, negative 390. So that's more than one full rotation in the negative direction. How much more? 30 degrees more. Negative 30 degrees more. So I'm going to go negative 360 degrees and then negative 30 degrees more. Start at your positive x-axis. I'm going to go negative 360 degrees, so that's there, okay? And now I need to go 30 degrees more. So I'll go 30 degrees more. I'll end up about right there, and then I can draw my terminal side. So notice sometimes I draw the terminal side first because I think about it. Sometimes it's like not visually popping into my head, but make sure you put an arrow right there. So I'll draw the whole angle first and then, or the rotation first. Okay. So, as we said, a full rotation is 360 degrees or 2 pi radians. So, radian is just another way of measuring angles, okay? So, just like if I said, like, how far am I from the wall right now? Someone could say, I'm 6 feet from the wall, or someone could say I'm 72 inches from the wall, or someone can give it to me in meters or yards, right? So, there's so many different ways of measuring that we know. When you're first introduced to angles, it's always degrees. And then in Algebra 2 with trig, we throw in radians, okay? So a radian is just another way to measure an angle. So how do we convert between radians and degrees? So to figure out how we convert, let's think about it this way. How many degrees are in a circle? 360 degrees. How many radians are in a circle? 2 pi. We can set these two equal to each other and solve for 1 radian or solve for 1 degree to see how we can convert from the other. Once we do convert, or once we figure out the conversion, it's easy to like know how to convert. Okay, so let's see how to convert We'll do 360 degrees is equal to 2 pi radians. And this time I'm going to solve for a degree. So how to convert degrees to radians here. So if I want this to be 1 degree, so I can see the ratio here, I'm going to divide both by 360. Divide by 360. So I know 1 degree is equal to, and then simplify this fraction. This fraction is simplifiable. 2 goes into itself once. 2 goes into 360 180 times. So it's equivalent to pi over 180 radians. Okay, so that's your conversion. And then vice versa, if I have, I'll write 2 pi radians on the left side because I just like having that, equals 360 degrees. So now if I wanted to solve for 1 radian, how do I get 2 pi radians to be 1 radian? I divide by 2 pi. So divide by 2 pi, divide by 2 pi. 2's cancel, pi's cancel, you're left with 1 radian is equivalent to, and then this fraction is simplifiable. 360 and 2 are both divisible by 2. It goes in there once. It goes in there 180 times. So 180 divided by pi. Okay. So there's your conversions. So in other words, to convert a degree measure to radian measure, we're going to, if I have degrees and I want it to be radians, I'm going to multiply by pi over 180. If I have radians and I want it to be degrees, I'm going to multiply by 180 over pi. Right? Now, people are like, wait, which one's which? Which one's which? Think. You'll see that you think. Okay. So this is convert each to radians. So first off, all of these are from the unit circle, but I'm using ones that you already know, have already seen before, so that it makes sense that, oh yeah, that does convert to that. Oh yeah, those are equal. So if I asked you 45 degrees, how many radians is that? You might be saying I already know the answer, but let's see why it works. So this is degrees, I want it to be radians. I want pi in my answer. So if I want pi in my answer, I'm going to multiply by pi and divide by 180. And now I need to simplify this. So I need the biggest number that goes into 45 and 180. Some people get stuck and they're like, if you need to go little by little, it's fine. If you say 5 goes in here, okay, and then 5 goes in here 36 times. No, it doesn't. 5 goes in there. Let me think in my brain here. 180 divided by 5. It goes into 18 3 times. 3 times 5 is 15. 3, 0. Yes, it does. Come on, I can do mental math. It goes in there 36 times. And I said 5 goes in there, and I accidentally said 5 goes in there 5 times. That's why I was thrown off. My bad. I'm not starting my video over. So 5 goes in there 9 times. 5 goes in there 36 times. And be like, wait, 3 goes into both of those still, or 9 goes into both of those still. 9 goes in here once. 9 goes in here 4 times. It's pi over 4. Right? But a faster way of doing, oh, I don't want to erase all of that. Come back. A faster way of doing that is to say, what's the biggest number that goes in there? The biggest number that goes into 45 and 180 is 45. 45 goes in here once. 45 goes in here 4 times. It's pi over 4. Right? So you can get there no matter what, unless you make silly mistakes like I just did. Okay, this is in degrees. I want it to be in radians. So I'm going to multiply by pi and divide by 180. I need to simplify this. The easiest way to simplify this is I see that they both end in 0, so 10 goes into both. And then 3 goes into both 15 and 18. So 3 goes in here 5 times. 3 goes into here 6 times. So it's 5 pi over 6. So 150 degrees is equivalent to 5 pi over 6. This is an angle from the unit circle, 150 degrees, and 5 pi over 6 is its equivalent radian. All right, this is in degrees. I want it to be in radians, so I'm going to multiply by pi and divide by 180. 90 goes into itself once, and it's negative. 90 goes into 80 2 times, so this is negative pi over 2. Notice I'm putting the negative in front. You can put the negative In front, it looks the best, or you can put it in the numerator. Please don't put it in the denominator. 30 degrees, you might be saying, I know what it is. Well, make sure that you, at some point, I want you to memorize this, but make sure that you know how to convert. That's the whole point of the practice. 30 goes into itself once, 30 goes in here 6 times. So it is pi over 6. Multiply by pi, divide by 180, because it's in degrees, I want it in radians. So the biggest number that goes into 180 and negative 135. So once again, if you're like, I don't know the biggest number, well then pick a number that goes in there. If you have to say 5 goes in there and break it down, because 5 goes into both, then do it that way. And then you'd see that 9 goes into both. So if 5 and 9 both go into both, that means 45 go into both. 45 goes in here negative 3 times. 45 goes in here 4 times. So I have negative 3 pi over 4. Next one, it's in degrees. I want it in radians. So I'm going to multiply by pi and divide by 180. So 90 goes into both, or you can say cross off the zeros because 10 goes into both. 9 goes into both of those. Negative 3 times, 2 times. So I have negative 3 pi over 2. Okay. All right, now let's do some converting to degrees, okay? So this is in radians, and I want it to be in degrees. Is there pi in degrees usually? No, so I want to get pi out of my answer. So what I like to do is I like to extend the fraction bar and say I need to get pi out of my answer, so I'm going to divide this by pi because the pi's will cancel then. But that means I'm multiplying by 180. And then you simplify that. The pi's cancel, and then I have to do 180 divided by 3. 3 goes into itself once. 3 goes into 180 60 times. So this is 60 degrees. Once again, pi over 3 is a radian measure that you should have memorized from the unit circle that is 60 degrees, but we're just making sure we know how to convert. Okay, once again, I need to get pi out of my answer. So I'm going to divide by pi and multiply by 180. Pi's cancel. Now, this right here, realize I have to multiply these two numbers and divide by this number. But it doesn't matter the order that I do it in, okay? So what I like to do is I like to divide first to make the number smaller before it gets bigger. So I say divide by 2. This is divisible by 2. 2 goes in there 90 times. And then negative 3 times 90 is negative 270 degrees. Next one, I need to get pi out of my answer and then multiply 180. Remember, and it's because this says convert to degrees. Pi's cancel. Once again, I'm going to divide by 3 first. 3 goes into 180 60 times, and then do 5 times 60, which is 300 degrees. This is in radians. I want it to be in degrees. I need to get rid of pi. Divide by pi, multiply by 180. The pi's cancel. 6 is divisible by 6 1 time. 180 is divisible by 6 30 times. Negative 7 times 30 is negative 210. Here, this is in radians. I want it to be in degrees. I need to get rid of pi, so I'll divide by pi. That means I'm multiplying by 180. Pi's cancel. 4 goes into itself once. 4 goes into 180 45 times. Then I need to do 45 times 11, which I don't have memorized, so I'll just do this math off to the side. 5 times 1 is 5. 5 times 4, 4, 0, 0, 5, 4, 450, 495. I know you just heard me babble numbers, but anyway, you multiply is fine, as long as it's not using a calculator. All right, I need to get this into degrees. So you might be saying, I know it's 45, but once again, the whole point is to show how to convert. So when we give you these ones, when we're testing you on these, it won't be ones that you have memorized from unit circle. So I'm going to divide by pi. I'm going to multiply by 180. Cross off those. 4 goes into itself. 4 goes into 180 45 times. So this is 45 degrees. Okay. So the last thing we're going to talk about are coterminal angles. Coterminal angles. So this is a vocabulary word that you have to know. So first off, I want to show you an example of a pair of coterminal angles in degrees or radians. It doesn't matter. I'm not going to even give an angle measure, okay? So if I have this angle right here, I'll show you another angle that's coterminal. So I'm talking about, let me change colors here, this green angle right here. So that starts at this initial side and goes to this terminal side. So it is coterminal. It means it has the same terminal side as this angle is coterminal to it. This angle, so a 360 degrees, and then keep going and hit that that's coterminal to it, and so on and so forth. So notice if I knew that this was 30 degrees, okay, that green one, what would the blue angle be? Together they make a full circle, so 360 from that, or minus 360 from that, that angle is negative 330 degrees, right? If I want to know the purple angle, it's 30 degrees and 360 more, so that's 390 degrees, okay? So if you look, if I have 30 degrees and I want it to be negative 330, I subtract 360. If I have 30 degrees and I want to get it to be 390, I add 360. So to get coterminal angles, all you have to do is add or subtract 360 degrees 1 time, 2 times, any multiple, okay? For radians, it's 2 pi. If I want to get something that's coterminal to it, I can add or subtract 2 pi to it. So these directions say identify all angles that are coterminal with the given angle, then find and draw one positive and one negative angle coterminal with the given angle. So let's start with the directions are kind of long here. So we're going to do this, identify all angles that are coterminal with the given angle. I'll highlight that in pink in the first one. After I'm done doing it, I'll find and draw one positive angle, and I'll do that, highlight that in yellow when I'm done, and one negative angle. And I'll highlight that in green when I'm done so we know what's what. Okay. So I'm given 45 degrees. I'm going to start by finding an angle that's coterminal to it that's positive. All I have to do is do 45 degrees plus 360 degrees. So that is 395 degrees. So now it says it wants me to draw that. So to draw a 395 degree angles, here's the easiest way to do it. Okay, use this for help. Where's 45 degrees? This is my positive x-axis right here. Well, that's not helping. This is my positive x-axis right here. 45 degrees is in counterclockwise direction, and it's still in the first quadrant. So there's 45. So drawing your terminal side is going to be helpful. Now I can show 495 degrees. I'm going to start at my initial side. I'm going to go full 360 and then stop at my terminal side. So that was one positive angle, and I drew it also like it asked me to. So this, and then this is for the first one. All right, now it also says find a negative angle. So I'm going to do 45 degrees minus 360 degrees. So that's going to be negative 315 degrees. And now I'm going to draw that. Okay, so I already know my terminal side is right here. It's that 45 degree angle. And now I'm going to show my negative 315. You always start at your positive x-axis. And then you're going to go clockwise until you hit that side. So this, what color did I say I would do that in? Green. So this is my negative angle, and here's my negative angle drawn. The last thing I want to do, actually it could have been the first thing I did, was identify all angles that are coterminal to it. So all angles that are coterminal to it is 45 degrees plus 360 n, where that's n can be any number. So 360 once, 360 twice, 360 3 times, 360 negative 4 times, any integer it could be. And those will all be coterminal. So if I say 360 times negative 2, that's subtract 360, subtract 360, all right, from 45. And that is the all angles that are coterminal. Okay, so we'll try 2 more in degrees, and then we'll switch to radians, and then there's 2 for you to try on your own. I'll tell you the answers and show you what they look like so that you have practice on your own here. Okay, so let's start off with the any angle. That's negative 130 plus 360 n. That's nice and easy. Okay, so that's any angle. Now let's do a positive angle. So I'm going to do negative 130 degrees plus 360 degrees. So negative 130 plus 360 is 230 degrees. So now I'm going to draw that. So I need to draw 230 degrees. So here's my positive x-axis. You don't have to draw that part if you don't want to, just so you realize. But I want you to realize that we're always starting there. And then 230 degrees. So this is 90, 180. And then if I go this far, it's 270. So I want to go less than that. So I'm going to go 90, 80, and then I need to go 230. So that is not pretty, but I'm going to leave it because I'm going to not be that sad about it. And it's that angle right there. Okay? Got to put an arrow. All right. Next one is that I need to find a negative angle. So I'm going to do negative 130 minus 360. And that is negative 490 degrees. So first off, I already decided where my terminal side is. It's right here. It can't change because they're coterminal. So now I just need to show the negative 490 degrees. So remember, you have to start at your positive x-axis. So I'm going to put a little dot there so you can see it. So I'll start there. I'm going to go this direction because it's negative, right? And I'm going to go one full rotation, and then I'm going to keep going until I hit my terminal side, okay? So I'll start here, keep going. There's 360 degrees, and then I'm going to keep going until I hit my terminal side, and that's my angle. So notice it starts at my positive x-axis, and then it goes a full rotation and then more. So there is that answer. Okay, so one thing I will say is don't forget to draw them in your homework, that we do ask you to draw them on your test. All right, 375, I need a positive angle. So first thing I notice is this is more than 360. So I'm going to get a positive angle by subtracting still because I'll still be positive. So that's 15 degrees. Drawing that is super easy. 15 degrees is in my first quadrant. It's right there. Done. All right, now I need a negative angle. So if I do 375 minus 360, I'm still positive. So I'm going to do 15 because that's still coterminal minus 360. Or I could have done minus 360 twice. I could have done 2 times 360, which is 720 from 375. Okay. So this, remember, if you didn't get what I just said, this is 375 minus 60, which is this, and then minus 60 again. Okay, 360, my bad, which is negative 345 degrees. All right, drawing it, I know it ends in the same exact spot as 15 degrees would, but now I have to draw negative, so I'm going to start at my positive x-axis, go clockwise, and then until I hit that. Okay, it's not negative 360, so I'm not going to keep going, but that's where I stop. Okay, why don't you pause the video and try H on your own really quick, and then I'll just write down the answers so you can check them. Your angle, I forgot to do angle coterminal, all angles here. So this is 375 plus 360N. Okay. So this one would be 50 plus 360N. And then the angle that's coterminal would be 360 plus 50, which is 410 degrees. 50 degrees is in this quadrant, a little bit more than 45. And then if I want to show 410, positive x-axis, a full 360, but then stop at the terminal side. Then if I want a negative angle, 50 minus 360 is negative 310 degrees. It's going to end in the same spot. I'm going to go start at the positive x-axis and go in the opposite direction. All right, now let's do radians. Okay, so for any angle that is coterminal to pi over 2, I would have to do pi over 2 plus, and I'm not going to put 360 in because I'm not going to say I add degrees to radians. I'm going to say plus 2 pi n. That is going to be any angle. All right, so now to get an angle coterminal, I'm going to do pi over 2 plus 2 pi. Okay. Realize I have a fraction that I have to add with a non-fraction, so I need to get a common denominator. So I'm going to put this over 1, and my common denominator is 2, so I'll multiply this by 2 and multiply this by 2. So this becomes 4 pi over 2, right? So pi over 2 plus 4 pi over 2 is 5 pi over 2. That is my coterminal angle. And now I'm going to draw it. Okay, so 5 pi over 2 is in the same place as pi over 2. Where's pi over 2? Pi over 2 is the same thing as 90 degrees. 90 degrees is right here. Okay, so 5 pi over 2 is 90 degrees, but then 360, sorry, I keep saying, yeah, it's 90 degrees. It's 90 degrees and 360 degrees more. So that's pi over 2, and then I have to go 2 pi more, and it'll end right there. Now I can do pi over 2 minus 2 pi. Now remember, I already got a common denominator, and it was 4 pi over 2. So that is negative 3 pi over 2. So now to show that, my terminal side is going to be there no matter what. Go to your positive x-axis, this time going in negative direction. All right, next one, negative 3 pi over 2. Any angle is negative 3 pi plus 2 pi over n, 2 pi n. Now I'm going to get a positive angle, so I'm going to have negative pi over 3 plus 2 pi. Put it over 1 to get a common denominator. My common denominator is 3, so I'm going to multiply this by 3, multiply this by 3. So this becomes 6 pi over 3. Negative pi over 3 plus 6 pi over 3 is 5 pi over 3. Okay? If you're not that good with radians, you might be saying, I don't know where 5 pi over 3 is. Well, do you know where negative pi over 3 is? So if this is 0, and I want to go negative pi over 3 in this direction, I know that pi over 3 would be right here, so negative pi over 3 is right here. You could also always convert pi over 3 to degrees to help you. So 5 pi over 3, let me erase this because is going to end up right here. That's the terminal side. But now I want to draw 5 pi over 3, which is a positive angle. So that's this angle right here. Negative pi over 3 minus 6 pi over 3. I'm not going to write minus 2 pi because I know I have to get a common denominator. It's negative 7 pi over 3. Drawing that. Here's my terminal side. And now I want to go negative 7 pi over 3. So I'll start at the positive x-axis, go in the negative direction. I'm not stopping there because that's just negative pi over 3. I need to keep going. A full rotation, which is 2 pi, and then pi over 3 more, which is negative 7 pi over 3. All right, last one together here. I need an angle that is coterminal. So 9 pi over 4 is more than 2 pi. Any coterminal angle is 9 pi over 4 plus 2 pi n. But 9 pi over 4 is more than 8 pi over 4. And 8 pi over 4 is 2 pi. So this is more than a full rotation. So to get a positive angle, instead of adding, which you could add 2 pi, I'm going to subtract 2 pi because I will still be positive. Common denominator of 1. I need this to be, common denominator needs to be 4. Multiply by 4. This becomes 8 pi. So I have 9 pi over 4 minus 8 pi over 4, which is pi over 4. So that's my first angle that I want to graph. Pi over 4 is in my first quadrant. It's the same thing as 45 degrees, so it's this angle right here. Then I can get a negative angle, so I have to do 9 pi over 4 minus 2 pi, or I can do pi over 4 minus 2 pi, which is 8 pi over 4. That's negative 7 pi over 4. Still going to end right here, and I just have to show the negative angle now. So I go to my positive x-axis counterclockwise until I hit the terminal side. Okay, we have one for you to try if you feel good. You can go ahead and get started on the homework or the next set of notes watching those. If not, you can pause the video and try it and check your answer. So any angle is negative pi over 6 plus 2 pi n. A positive angle, I would have to add 2 pi. My common denominator, or make a denominator, and then my common denominator is 6. So multiply this by 6, and I get 12 pi. Negative pi over 6 plus 12 pi over 6 is 11 pi over 6. Okay, if you're really good with unit circle, you should know where 11 pi over 6 is. If you're not that good with unit circle, you should know where negative pi over 6 is. Here's the positive x-axis. If I have to go in the negative direction, this right here is a negative pi over 6. Now, I want to graph 11 pi over 6, so I have the same terminal side, positive x-axis until I hit that side. Negative angle, I'm going to do negative pi over 6 minus 2 pi, which is minus 12 pi over 6. It's an equivalency. So I get negative 13 pi over 6. So drawing that, I know my terminal side's right here. Now I need to draw my negative angle. So I don't want to just stop right there because that's negative pi over 6. So I'm going to go full 2 pi and then that pi over 6 more, and that's negative 13 pi over 6. All right, that's it for degrees to radians, radians to degrees, and drawing coterminal angles and finding coterminal angles notes. You can go ahead and either get started on the bookwork, or you can watch the next screencast on notes.